Okay, so in this video, we're going to start finding key values around our unit circle. Remember, the unit circle is a circle with radius equal to 1. And so one of the first things that I tell students to do is when we're first starting this out is to plot these points. So if we're dealing with a radius of 1, and we talked about this, this will be the outside of the circle. And so if we plop it on a coordinate graph, the center being the origin, then this value is 1, 0. This value is 0, 1. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then we're back at 360, completing one full revolution. And so that means, just think about, well, if it's a radius of 1 and I'm moving in this direction to this point, I've moved 1 unit backwards on the x value, and I have not moved up or down at all. And so I plot these points, and that gives me 90-degree rotations, which should be the easiest things to do, which you should be able to complete by memory. So the question is asking, find sine of negative 90 degrees. So I have to think about, well, my rotation of negative 90 degrees, so the rotation is backwards, right? So this is a rotation of negative 90 degrees. And in the previous videos, we know that our cosine value of any angle when we're in the unit circle is equal to the x value, and the sine of any angle is equal to the y value. And so I know that my y value is negative 1. So what that means is sine of negative 90 degrees is going to equal, negative 1. Okay? So I use the y value at that rotation. For our next example, tangent of 540 degrees. Well, 540 degrees, okay, it's not a full, it's beyond the 360-degree revolution. So what I do is I think about, okay, well, if I subtract 360 and just do some basic math here, if you don't know what it is in your head. I don't know why I put a 2 up there. That should be a 4. So apparently basic math for me is pretty hard. But that gives me 180 degrees. So I think about all these 4 points around the circle. I know that this point is 1, 0. This point is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. So 180-degree rotation is all the way to here. Well, and I want tangent. Okay. Well, so if sine of an angle is equal to y, cosine of an angle is equal to x, this is our opposite side, this is our adjacent side, and tangent is equal to opposite over adjacent, so tangent is y over x. And so for this one, I'm going to go ahead and say, okay, well, tangent of 180 degrees is equal to the y value over the x value, so that's equal to 0. And one of the things that I do, let me shrink this, one of the things that I do to remember tangent, if tangent of an angle is equal to y over x, and I notice here it's got this y over x. Well, tangent is actually the change in y over the change in x, which is our slope. So what I do is I look at this line right here, and I think to myself, what's the slope of this line? It's a horizontal line, so slope is equal to 0. So any tangent value that's on the 180 line is going to equal 0. And by that same rationale, I'm going to do a quick extra example. If I asked for tangent of 90 degrees, tangent of 90 degrees is going to equal my y over x, and x in this example is 0. So that means tangent of 90 degrees is undefined. Well, let's look at our grid again. This line right here is a vertical line. And if we remember this little, way to remember it, vertical is undefined and it's an x is equal to. So the equation, the line would be x is equal to 0, but it's an undefined value. So anytime we're on any of the 90s, which could be 90 or 270, we're going to deal with an undefined tangent value because we're dividing by 0. And that's one of the quick ways that I remember tangent, whether it's on the 180 line or on the 90 line.